mathematicians. Today we see one nice linear algebra problem asked in the CSIR exam. It is a part C problem. Let A equal to Aij be an n by n complex matrix and A star denote the conjugate transpose. So A star equal to A bar transpose. Which of the following statements are necessarily true? Okay, so basically this question is about this number trace of A star A. You calculate the matrix A star A, then it's find its trace. Okay, so all the options are regarding trace of A star A. So before going into the options, first we see what is this number. Okay, then we'll go to the option one by one. Okay, now let's consider this 2 by 2 matrix. Let's understand this number for 2 by 2 matrices. If A equal to ABCD, then A star equal to A bar transpose. So first you have to take bar, then you have to take the transpose. When you take transpose, these two numbers get interchanged. Okay, so we got this number is A star, this matrix is A star. Now A star A, if you multiply, you will get this matrix. Now trace of A star A would be sum of the diagonal entries, that is A A bar A plus B bar B plus C bar C plus D bar D. Okay. Uh, Therefore, trace of A star A, we got this number. Now, Z bar equal to mod Z square. Okay, that we know from our complex analysis course. So, trace of A star A equal to mod A square plus mod B square plus mod C square plus mod D square. Now, if you look at this 4 by 4 matrix as a vector in C power n, then it has our usual norm. So, which is defined to be square root of A bar plus B bar plus C bar plus D bar. If you calculate it, you will get again square root of mod A square plus mod B square plus mod C square plus mod D square. Okay, and this trace of A star A is exactly giving you the same value. So if you define norm of a matrix to be square root of trace of A star A, this will defines you a norm in the set of all 2 by 2 real matrices, 2 by 2 complex matrices. In general, for n by n matrix also you can define uh, norm of A to be square root of trace of A star A. Okay. So since this defines a norm on matrices, we get norm A equal to 0 if and only if A equal to 0. That means that square root of trace of A star A equal to 0 if and only if A equal to 0, or equivalently trace of A star A equal to 0 if and only if A equal to 0. So that is our first observation. Now using this observation we can now do the problem. If you already know this trace of A star A defines a norm, then you can just immediately do this problem. Uh, Now given you know this is a norm, there are other questions also in the CSA problem asked regarding this quantity. Now you can answer them also. So let's try this problem. Okay. First option they are saying that if A is invertible, then trace of A star A is not equal to 0. Okay. So if A is invertible, then definitely it is a non-zero matrix. If it is a non-zero matrix, then its norm will be definitely not equal to 0. Therefore, trace of A star A will be not equal to 0. Okay. If you want to see it in a different way, you see if A is an invertible matrix, then at least one entry will be non-zero entry. Okay. If at least one entry is non-zero, one of this term will be positive. Okay. Therefore, in total, this value will be positive. Okay, so therefore trace of A star A not equal to 0. So first option is correct. Second option says that if trace of A star A is not equal to 0, then A is invertible. Okay, so if trace of A star A is not equal to 0 means that one of this number is non-zero. Okay, so you see this is sum of non-negative numbers. Sum of non-negative numbers is 0 if all of them is 0. Okay, so if this this if this if this sum is non-zero, That means not if not equal to 0 means that at least one entry is positive. Okay, so we only know that at least one entry is positive. We don't know whether it is invertible or not. For example, you take this matrix 1001. If you calculate its trace of A star A, you will get 1 plus 0 plus 0 plus 0. So trace of A star A will be 1. Therefore, this condition is satisfied, but A is clearly not invertible. Okay, so second option is false. Now, if maybe we'll do the last option first. If trace of A star equal to 0, then A is a 0 matrix. That is basically this condition only. We know equal to 0 if and only if A equal to 0. So they are asking this direction. If trace of A star A equal to 0, then A is a 0 matrix. Yes, the answer is true. If you want to see it, like again, you can see it here also. If this quantity is 0, then each of this A, B, C, D has to be 0. Then basically that means that the matrix is a 0 matrix. Okay. Now, in the third option, they are saying that if modulus of trace of A star A is less than n square, then mod Aij is less than 1 for some I comma j. Okay, so now we are doing 4 by 4 matrix. So, sorry, 2 by 2 matrix. That means this quantity is 4. So, suppose if this quantity is less than 4, we want at least one of A, B, or C, or D has modulus less than 1. Okay, if each of them have modulus greater than or equal to 1, then definitely their sum will also greater than or equal to 4. Okay, so you are summing four numbers which each of them is greater than or equal to 1, then the sum will be greater than or equal to 4. But it is given that it is less than 4. Therefore, not all of them can be greater than or equal to 1. Therefore, at least one of them should be less than 1. That is the same argument for n by n matrices also. So, if it is a n by n matrix, here you will have n square n summands. Okay, for each matrix entry, you will have a summand here. And if it is strictly less than n square means that not each term can be greater than or equal to 1, because if each term is greater than or equal to 1, then sum will be greater than or equal to n square. Okay, therefore there will be a matrix entry whose modulus is less than 1. Okay. Okay, so this is a part C problem. I hope you understand. If you learned something new from this video, please click the like button and share with your friends and subscribe to my channel. Thank you.